Hello guys, welcome back to Engineer 1. Today we're going to be doing a mechanics of materials problem. So in this case we have to determine the maximum in-plane shear stress in the given element. So when you see a problem like this on your FE exam, what you're going to do is you're going to go to the FE review manual, page 133, and you're going to find these two formulas right here. As you can see, the diagram that we're given is basically exactly what we have over here for our given element. You probably remember this from the mechanics of materials class. So we're going to be using this formula right here, which is used to find the radius of Mohr's circle, but it will also work to find the maximum in-plane shear stress, which is what we need to do for our given problem here. So now that we know the formula that we need to use, all we need to do is we plug in the values that we were given. So I went ahead and filled out some of the formula here. We have 0 applied shear stress on the element that we were given. So that's why I have a 0 here. And then once we go ahead and we take a look at our applied stresses, we see that the 12 psi is in compression in this case. So if it was in tension, it would be positive according to the diagram we were given on the FE review manual. But because it's in compression, we're going to put negative 12 instead of positive 12 here, which is where the applied force in the x direction goes according to our formula. And then for the next one, the 4 psi, that one is also in compression, so it's also going to be negative. So in this case, it would be minus negative 4. So we're going to do plus 4. And then once you go ahead and you solve that, you're going to get that the answer is 4 psi. So that one was a pretty straightforward problem there. That is how you solve a mechanics of materials problem where you're given an element with applied normal stresses or shear stresses. You just use this formula, and you can use this diagram here to kind of guide you through the positive sign convention and how you're supposed to use the formula in that case. So if you would like to see more videos like this in the future, make sure to subscribe to the channel, make sure to leave a like and comment on any feedback, and I'll see you in the next video.